So let's go ahead and apply the rules that we know about naming alkanes and now haloalkanes toward coming up with an IUPAC name for this molecule, including the designation of stereochemistry. So when we say including the designation of stereochemistry, what we're referring to here in this molecule that has just carbon-carbon single bonds is if there's any chiral centers, we need to specify them as R or S and include that as a prefix at the beginning of the name using parentheses to indicate the location of where the chiral centers are and what their stereochemistry is whenever possible. So let's take a look at this problem. First and foremost, going back to that list of guidelines, we're going to find the longest continuous carbon chain there in step 1 to come up with the parent name. And then after that, at step 2, we're going to number the parent chain beginning at the end closer to a branch, closer to a substituent. And remember that we're not prioritizing a halogen branch over an alkyl branch. We're just looking for where's the branch that's closest to the end of the molecule. So let's find the longest carbon chain here. And remember that that's the longest chain we can go through without having to lift our pen or pencil or backtracking. So look for the longest carbon chain. And the longest carbon chain, I believe, is going to be going from here. I'm highlighting this in green, all the way through like so, to here. All right, so that's our longest carbon chain. We're going to count up how many carbon atoms are in that longest carbon chain. I come up with 8, and I hope you do too. And now what we're going to do, since we've come up with the longest carbon chain, is assign the parent name of octane. So our parent name is octane, which I'm specifying in green here to color code that the same as we did our highlighted longest carbon chain. Now we need to name all the branches that come off of that highlighted longest carbon chain. So we have an ethyl branch, we have a methyl branch, and we have a fluoro branch. And we need to number this longest carbon chain so that we put a branch as close to the end as possible. So we have 2 choices here. One is we can start numbering from the left, so we go 1, 2, 3, putting the fluorine branch at carbon 3, or we can start numbering from over here, going 1, 2, 3, and we run into a little problem here because in both ways of numbering from the left or numbering from the right, in both situations we end up with a branch coming off at carbon number 3. So what do we do here? We go back to those rules, and we see there at step 2 that if 2 different branches are equal distances from the end, we start numbering the chain from the end closer to the branch that comes first in the alphabet. And so, looking for the branch that comes first in the alphabet, we have a fluoro branch at carbon 3, numbering from the left, versus an ethyl branch. If we start numbering from the right, ethyl comes before fluoro in the alphabet, and so therefore, we're going to start numbering from the right-hand end of the molecule. So I'm going to go ahead and erase these numbers from the left since that's what we decided not to use here. So going from the right-hand side, working our way left, our 8 carbon chain, and we're numbering from the end closer to the branch that comes first in the alphabet since we had a tie there at where the first branch came off. So 3 ethyl group, 5 methyl group, and 6 fluoro group, branching off of our parent chain. We need to list all of those out in alphabetical order in the name here. So ethyl, fluoro, and methyl, putting those in alphabetical order. I believe ethyl is going to come first here. So we have 3-ethyl. Remember, we always separate our numbers from letters using dashes. So 3-ethyl dash 6 fluoro dash 5 methyl, and the term methyl and octane run together there as one word. And then the last thing that we need to do here is specify the stereochemistry. So the RS chirality at each chiral center in the molecule where we have wedges and dashes shown so that we can tell what the chirality is at those locations. I'm going to put in parentheses here at the very front of the name the 2 locations where we have chiral centers that we can specify. So we have at carbon 5, there's a chiral center, which I'll put a star right there. And at carbon 6, there's a chiral center. So I'm doing 5, 6. And we're going to fill in that empty space there, right here and here, that I've left an underlined blank spot for, with the RS chirality at chiral carbon number 5 and chiral carbon number 6. So let's go ahead and do that. So in order to determine the chirality at carbon number 5, remember that we have to have a tetrahedral carbon in order to assign stereochemistry. The part that's missing from the tetrahedron, we have 2 lines, a dash, and therefore the wedge is what's missing, and that has to be a hydrogen bonded there. Now we're going to rank the 4 groups that are bonded at this location. The 4 groups that are bonded at this location starting from the lowest ranking, is our hydrogen atom. I'm going to go ahead and put that hydrogen in as number 4 there in blue. And then we have a methyl group, we have the chain leading toward the fluorine atom, and we have the other alkyl chain going there toward carbon 4 and onward. So we need to rank those 3 groups. In order to do that, what I'm going to do is look at what's bonded to each of those 3 carbon atoms. So I'm drawing 3 kind of squiggly lines there to specify where we're looking at. So looking at the methyl group, we have a carbon that's directly bonded to 3 hydrogens going away from the chiral center because of the CH3 group. So we put CHH. Coming here to carbon number 4, we have our carbon atom. We ask ourselves what 3 atoms that carbon is directly bonded to. That carbon is directly bonded to another carbon going away from the chiral center to carbon 3. And it's also directly bonded to 2 hydrogens since it's a CH2 group. So we'll go ahead and plug that in. And then we come over to carbon number 6. Carbon number 6 I'll put right here. And then list in order from highest atomic number to lowest atomic number the 3 atoms that carbon is directly bonded to. It's bonded to an F for fluorine, bonded to a C for carbon, that's carbon number 7, and it also has to be bonded to an H there. So we have those 3 listed in order from highest atomic number to lowest atomic number. Now, coming up with the relative rankings of these 3, we're looking for, remember, the highest atomic number. In each of the 3 cases that we've outlined in blue there, we have a carbon atom first off. And then, since those 3 carbon atoms are the same, we have to look at the next atom in line there. That's a fluorine, a carbon, or a hydrogen. Going based on atomic number, fluorine has the highest atomic number, and therefore fluorine is going to be the highest ranking. Going toward fluorine is going to give us the highest ranking group. So we'll go ahead and do that. So we go ahead and put this in as number 1. Number 2 is going to be headed toward carbon number 4 because that's the second highest ranking group. And third highest ranking group is going to be that methyl group. So now we draw our circle connecting the highest ranking group over to second highest, over to third highest. So going from 1 to 2 to 3. Remember, we ignore that 4th ranking group for this circle that we're drawing. So going from 1 to 2 to 3 takes us clockwise. And then remember that that orientation assumes that the hydrogen is pointed away from us. If the hydrogen instead is pointed toward us, we flip what we come up with as our assignment. So this is therefore going to be an S chiral center. So we'll go ahead and call that position number 4 as position number 5 of our carbon chain as 5S. So S it is. Then we need to do the same thing there for carbon number 6. So what I've done now is just erased the scribbles that we put on the structure for determining the chirality of carbon number 5, so that now we can come over and look at a clean structure to determine the chirality at carbon number 6. At carbon number 6, of course, to fill in the complete tetrahedron, what's missing is the dash that goes to a hydrogen, so I'll go ahead and fill that in, and while I'm at it, I'm going to go ahead and rank that as number 4 because hydrogen has the lowest atomic number. Then what we need to rank is looking at the atoms directly bonded to that chiral center. We have a fluorine, a carbon at carbon 5, and the carbon at number 7. So ranking those 3 groups relative to one another, hopefully you recognize that the fluorine has the highest atomic number. Therefore, fluorine is our number 1 ranking group there. Now our task turns to ranking the relative priority of carbon number 5 relative to carbon number 7. So at carbon number 5, we have, as we'll put in parentheses here, directly bonded there, we have the carbon of the methyl group, the carbon at carbon 4, and we also have directly bonded there a hydrogen. So I filled in the brackets there with C, C, and H. We come over to carbon number 7, and we ask ourselves, what's directly bonded to that carbon? Well, directly bonded to that carbon is another carbon, as well as 2 hydrogens. So I'll go ahead and fill those in as well. Now, assessing the relative rankings of these 2 groups, we have in the first spot of each carbon versus carbon. We come to the second spot of each and we have carbon versus hydrogen. Carbon certainly has a higher atomic number than hydrogen, therefore we're going to put the higher ranking group over here. So that's going to be number 2 since we already assigned fluorine as number 1. Then our last remaining spot in this order of 4 is right here, has to be number 3. So now we draw our circle going from 1 to 2 to 3, 1 through 2 to end up at the bond leading to 3, takes us counterclockwise, and our hydrogen is pointed away from us. So therefore, this counterclockwise orientation we are going to assign as S. So we'll go ahead and fill this in as 6S, and that concludes coming up with the complete IUPAC name for this particular molecule. Let's do one more example problem of this. For this example, just like the last one, we're asked to provide the IUPAC name of this molecule, including the stereochemistry. Generally, when we say including the stereochemistry, what we're referring to be as specific as possible is we want to assign the absolute configuration, meaning we want to assign the RS stereochemistry at each chiral center within the molecule. So let's go ahead and get started with naming this molecule. First and foremost, when you're naming molecules that have a ring, the ring name is the parent name, and you specifically put the term cyclo in there to indicate that the atoms are part of a ring. So a cyclo ring that has 5 carbons is going to be named cyclopentane as the parent name of this molecule. We have to decide how we're going to start numbering this ring. We start numbering the ring from the carbon atom that has the branch, which would come first in the alphabet. So we have as our branches a bromo branch because of that bromine. And then this branch, looking back at that group of list of different alkyl branch names, you will hopefully see that this one matches the name isobutyl. You can recognize it as an isobutyl group because it has 4 carbons in total, 1, 2, 3, 4 that I put the little blue dots on. And with 4 carbons in total, it's going to be a butyl of some sort. And the term isobutyl indicates that at the next to the last carbon of the chain, we have a methyl branch coming off. So isobutyl is the name of this. The equivalent name that you could refer to this by is, if you wanted, you could call it, looking just within this branch, we have 3 carbon atoms in the branch, 1, 2, 3, and at carbon 2 of that 3 carbon branch is a methyl group, so we could also refer to this as 2-methylpropyl. So 2-methylpropyl would be a synonym that we could use for the isobutyl group. It is up to you how you want to do that. If you use 2-methylpropyl, remember that we have to put it in parentheses when we plug it into the name. So we'll use both of those terms when we go about coming up with the name for this molecule. In order to decide how we want to number our ring, we're going to start numbering the ring at which carbon atom has a branch coming off of it that comes first in the alphabet. So we're looking at isobutyl versus bromo. B for bromine certainly comes first in the alphabet, so we're going to put that carbon of the ring as carbon number 1. Then we take the shortest path around the ring to get to the branch that's next. So that's going to take us this way, 1, 2, 3, 4, 5. So at position 1, we have a bromine. Position 3, we have the isobutyl group. We plug those into our name here. And as usual, I've left myself kind of a painfully small amount of space here to write in the rest of the name. We'll make it work. So bromine is at carbon number 1. So we're going to fill in 1 bromo. At position number 3 of the ring is our isobutyl group, so 3-isobutyl. And then isobutyl is run together as one word with cyclopentane. Now, the last thing that we need to do here is specify the chirality, the stereochemistry that is, at carbon number 1 and carbon number 3, which is where we have our wedges and dashes indicating what is going on there stereochemistry-wise. So at carbon 1, our chiral center right here, we rank the 4 groups that are bonded there. Of course, our 4th group that's bonded is a hydrogen, which I show as a dash. I could have shown that as a dash to the right, dash to the left. It doesn't matter. It is our lowest ranking group. So I'm going to go ahead and plug that in as number 4. Bromine is going to be number 1 because bromine is directly bonded there and it has the highest atomic number. Then we have to distinguish between going in this direction toward carbon 2 versus over here to carbon 5. And what you will hopefully see is that this group right here is going to be higher ranking if we go through the full systematic lineup of coming up with ranking that group relative to over here, which I'm going to plug in then as carbon 3. So now, per the usual, we go from the bond that leads to the highest ranked group, second highest ranked group, third highest ranked group. Our hydrogen, fortunately for us, is pointed away from us. And so therefore, we just take the direction that this goes. It goes counterclockwise, so we describe that as S. So that is at position 1 of the ring, so we fill this in as 1S. We can do the same thing up here at carbon number 3. I'm just going to clean up the structure a little bit by erasing some of this garbage that we've used, or I should say sketches that we've used to determine the chirality at carbon number 1, and we'll go on to carbon number 3 for assigning the chirality now. All right, so let's go ahead and assign the chirality at carbon 3 now that I've cleaned up this structure a little bit. So in order to do that, we need to look at the 4 groups that are bonded to that carbon. Remember that there is a hydrogen. That hydrogen is pointed toward us, so that's going to have some implications when we go to assign this as R or S. We're going to go ahead and rank that hydrogen as number 4, the lowest ranking group. And then of the other groups, we need to take a systematic approach to assigning the rankings of those. This can get a little dodgy at times. We're going to walk through it here. So our 3 groups that we have to rank are the carbon atom here at position 2, the carbon atom here at position 4 of the ring, and the carbon atom right here that's part of the branch. So we ask ourselves what each of those 3 carbon atoms are bonded to. We put that in brackets here, and then we're going to compare what we see in the brackets for each of these to determine what the highest ranking is. So I'm just putting carbon and then brackets for each of these to get rolling on this. So over here at carbon number 2, we ask what that carbon is directly bonded to. As we go away from the chiral center, it's directly bonded to another carbon atom, headed toward carbon 1 there, and it's directly bonded to 2 hydrogens, so I'm going to put HH. We look up here at our isobutyl branch, and the carbon up there is directly bonded to another carbon. As we go away from the chiral center, it's also directly bonded to 2 hydrogens. Then we come over here to position 4 of our ring. We ask ourselves what that carbon at carbon 4 is directly bonded to. It's directly bonded to a carbon that's going on around the ring to carbon 3, and it's directly bonded to 2 H's. So we run into a little snag here because if you notice what we've written out in green is identical for all 3 directions. So therefore what we have to do is take one more step further down the chain or further around the ring, whatever the case might be, in order to assign relative ranking. So I'm going to put those in red to allow us to keep track of who's who. Half the battle here is staying organized with what you're dealing with and keeping track of a large amount of information. So at position 3 here, we'll go ahead and fill in what's directly bonded there. At position 1, we'll do the same thing because we're working our way away from the chiral center in each of the 3 possible directions, and then the 3rd possible direction is headed this way. So we'll go ahead and put up here C, and then what is directly bonded there. All right, so we're going to fill in here, here, and here as highlighted in red with what's directly bonded at each of those positions. So at position number 3 of the ring, what's directly bonded there as we go away from the chiral center is we have another carbon, that's at carbon number 1, and we have 2 hydrogens. So directly bonded to carbon number 3 is a carbon and 2 hydrogens as we work our way away from the chiral center. Coming over here to carbon number 1 of our ring, that carbon is directly bonded to a bromine. That's pretty high ranking. That's going to be hard to outrank. It's also going away from the chiral center directly bonded to a carbon. And finally, it's directly bonded to a hydrogen. So we'll fill in that. And then we come up to here at carbon number 2 of our branch up top. That carbon at carbon 2 is directly bonded to each of the 2 carbons of the 2 methyl groups. So I'll put in CC. And then that carbon number 2 of our branch in blue there is also bonded to a hydrogen. So we'll go ahead and fill that in. So now looking at these 3 groups that we've put in red, hopefully we can tell the difference between these, and looking at them, we indeed can, because bromine has a higher atomic number than carbon. So therefore, that's going to be our highest ranking group of those. And our second highest ranking group, looking here at carbon versus carbon, or hydrogen versus carbon. We can tell those 2 apart, and that means that the group up top is going to be higher ranking. So we'll go ahead and fill that in, and that'll allow us to give the order of these 2 here. So therefore, the order of these groups, going from highest atomic number rank to lowest, is that our highest ranking group coming from our chiral center, that carbon 3 is going to be right here, is the direction that leads to the highest priority because that's the one that has that bromine there that allowed us to differentiate. Second highest ranking group is going to be coming up to here to that isopropyl branch because we had the CCH there versus CHH down here. And then the third highest ranking group is going to be coming over to here. So now we go from 1 to 2 to 3 and determine whether we're going clockwise or counterclockwise in order to do that. So our highest ranking group was right here. Then we pass through the bond number 2. Then we come up and finish at carbon number 3. So that circle takes us counterclockwise, which we would typically say is S if the hydrogen's pointed away from us. But since the hydrogen's pointed toward us, the actual assignment is opposite that, which makes this an R chiral center. So we'll go ahead and fill that in as R. So we would assign then the chirality of carbon number 3 as 3R. So 1S, 3R, 1 bromo, 3-isobutyl cyclopentane is an acceptable name for this molecule. So with that, we conclude our walkthrough of naming alkyl halides, also known as haloalkanes. And in general, if you have down really well how to name alkanes and how to assign the RS stereochemistry, you have a major advantage in naming haloalkanes, because really the only difference between those concepts that we learned about assigning RS and alkane names is that we need to remember the names of the halogen branches, fluoro, chloro, bromo, and iodo. Other than that, you're going to go through the same types of rules that you've looked at before.